Hello, guys. I wanted to give a follow-up lesson to the lesson that we did last week about naming ionic compounds. Um, we talked about how when we're naming ionic compounds, what we're really doing is we're naming the ions that we see, and they're really the only change that we need to make from just the way the elements are listed on the periodic table is changing the nonmetal, which comes second. The second word, we're going to change the ending to "ide." So if you have two different elements in the ionic compound, a metal and a nonmetal, it's the nonmetal that you change the ending to IDE, ide. And we went through several different examples of what these can look like. Um, Sodium fluoride, calcium oxide. Notice that all of these just have two elements in them. And we can always tell how many elements are there, not by how many letters, but by how many capital letters there are. If I see a capital letter, I know that's an element, even though it's followed by a lowercase, and then another capital letter means another element. So I only have two elements in every single one of these, even though some of them have subscripts with them, which we'll talk about later on this week. But basically, every time I see a capital letter, that means it's an element. So two elements, and we talked about how the second one always ends in "ide." It would be nice if it just ended there, but it turns out that a lot of the chemicals that we deal with on a daily basis, especially ionic compounds, involve several different elements, really. And what I wanted to do was talk about how we can kind of distinguish those because they have their own sort of naming rules with them. So, what we talked about all the way up to this point are what we call monoatomic ions. Monoatomic ions are just one atom that becomes an ion. So some examples of that would be like sodium is Na plus 1 is a sodium ion. Okay, and another one would be like chloride would be Cl with a minus 1. Okay, or there's lots of different others. I'll give you one more. Aluminum would be another aluminum would be a monoatomic ion, Al, and that's a plus 3. Okay, so those are all just one element as an ion. But it turns out that there are a large number of ions that come up that are actually a group of elements together that makes up one ion. So it might be like several atoms bonded together that overall has a charge. So what we call this is a polyatomic ion. And you'll hear anyone in a chemistry class talk about these all the time because they get to be a little bit weird. There are lots of different kinds of ones, and they come up all the time. But the word polyatomic just means poly means more than one, right? So more than one atom ion. So ions with more than one atom in it. So what does that look like? Well, I'll give you two common examples here. So one that you hear about all the time is a nitrate ion. A nitrate ion it's actually four different atoms grouped together. It's a nitrogen atom and three oxygen atoms that are sort of bonded together, but this entire molecule has a minus 1 charge. So the oxygen and the nitrogen, and they don't bond separately. They bond as just one thing. So we just call this group of atoms a nitrate ion. So anytime you see NO3, you know that that has nitrate in it. Okay? So you may need more than one of these ions, but it's always going to be this combination, NO3. Okay? That means NO3 means nitrate. Another common one is cyanide. Cyanide is really just two atoms that have a charge overall, a carbon atom and a nitrogen atom. But this whole thing has one charge overall, just has a minus 1 charge. So when we see a C and an N together like this in an ionic compound, we call it cyanide. Okay, so there's really 8 of these ions that I want you to know. I can write the names for them right next to them. NH4 plus is the only positive polyatomic ion. All the rest of them are negative. So NH4 plus is ammonium. C2H3O2 minus 1 is acetate. CO3 2 minus is carbonate. Cn minus is cyanide. OH minus is hydroxide. NO3 minus 1 is nitrate, not nitride, which would just be an N by itself, but nitrate. So they line up here. And then two others here. There's this SO4 2 minus is sulfate, and PO4 3 minus is phosphate. So notice how these aren't the common "ide" ending that we're used to seeing. Now cyanide and hydroxide, I guess, have "ide" endings, but we see now that there's an "ate" ending on a lot of these. Another thing that's different is that, well, I guess for now we can kind of just ignore these charges because we haven't really talked about how to match up charges yet. But for now, what we should just be looking for is just the formula itself. If I see SO4 together, whether it's got parentheses around it or whatever, I'm going to call it sulfate. If I see CO3, capital C, capital O with a 3, I know it's going to be something carbonate. So we can do, it doesn't matter if there's parentheses or whatever. If you see those things together, NO3, I know I'm going to call nitrate. I'm not going to call it some goofy triple name like calcium, nitrogen, oxygenide, 2. Just call NO3 nitrate. You don't need to make up a goofy name for it. All ionic compounds just have two names, the positive name and the negative name. Okay? So if you see more than two capital letters, you know that, okay, one of those is a polyatomic ion, because polyatomic ion would mean that you have to have several atoms together just to make up one of the ions. Okay, so I'll go through a couple examples with you. Okay. Na is sodium, we know from your periodic table, but NO3 is one of the ones we just learned. Look, I've got 1, 2, 3 different capital letters, so I know that I've got a polyatomic ion here. So this is sodium. NO3 is nitrate. Al you can know is aluminum, but PO4 was one of the ones on the other page is phosphate. Aluminum phosphate. OH. OH is hydroxide. So I'm going to call this one calcium hydroxide. Now, notice how almost always the polyatomic ions are going to be the negative ion, the second one. But there are a couple situations where they come first. That would only be with ammonium. So K2SO4 would be potassium, is the K, but SO4 is sulfate. I get to this one, MgCl2. This is just, I only have two elements here. So I have to just go back to the regular "ide" ending on this. So magnesium and chlorine. So I'm just going to call this magnesium chloride. I don't need a special name because I don't have a polyatomic ion here. I've only got two elements total. AgNO3 would be silver for Ag, and NO3 again is nitrate. And here I've got parentheses again, but it doesn't affect my name. It just helps to show me that this is a polyatomic ion. Cn is cyanide. So this is zinc cyanide. I'd like you to practice these again for this week. I'll come back to you later this week with how we can come up with formulas. I have a worksheet that I'd like you to work on that looks really similar to the one that I posted last week. Only now it has some polyatomic ions mixed in. So some of them you can tell are in parentheses. Some of them you can see are not in parentheses, but you just have to kind of match them up with their proper names from the polyatomic ion list, which I just pasted here. Okay? Can you just make a copy of this Google Doc and with your answers filled in? A word about this, I noticed that a lot of us were just kind of Googling the first formula that came up, which I'm sure helps for a lot of them, but it's not going to give you the right answer every time, and it's not really going to teach you any rules about how to do this. Most of you are going to take chemistry eventually, and you're not going to be probably distance learning by then, and so this is a good rule to learn how to use. I can come up with some bizarre examples that you're not going to find when we have a quiz on this. So I really want to encourage you to um, practice learning the rules and not just typing in the answer to see what Google tells you right away. Okay? I will get back to you later this week.